Hello students, today we are in lecture number, which lecture? Do you remember? Yes, today we are in lecture number 7. Lecture number 7. What we were studying? Yes, it is vector quantity, which is very important. Student, today we will proceed. Student, we have studied about the vector. It is the quantity. Those are having the magnitude, direction as well. They obey the vector law of addition. Okay. Today we will study about the magnitude of a vector. All right. How we represent the magnitude. Because we know that the vector having the magnitude as well as direction. So today we will discuss about the magnitude of a vector. The student, we will use an operator to represent the magnitude, and it is called the modulus. In short, we will tell it is mod. Alright, your teacher will tell you about the mod, and the operator looks like this one. The two vertical bars. This is the operator called modulus. Remember, this modulus having the two uses. It is in mathematics and physics. Alright, in physics we used to represent magnitude, and in mathematics we used to represent the positive nature. Remember. Okay, if any quantity we put inside this modulus, then the output will be the magnitude. Okay, in course of physics. And in mathematics, if any quantity you put with the plus or minus here, the output will be only plus. Okay, what does it mean? If you put a vector A in this operator, vector A, the output will be the magnitude only. It will lose in the direction. Suppose if you are representing any vector as 50 meter east. Yes, remember this is a vector quantity. 50 meter it is the magnitude and east is the direction. If you are putting this 50 meter east in modulus, 50 meter east in modulus, then the output will be what? It is only 50 meter, direction gone. So this modulus used to represent only the direction. Okay, when we talk about the mathematics, if you're putting this plus or minus here the x, the output will be what? It is the x, that is the only plus x. So this modulus gives only the positive quantity. Whenever we want to make anything as positive, whenever we want to represent anything as positive, we use this modulus. Or if we want to represent the magnitude of any vector quantity, then we use this modulus. All right, if you are having the force, okay, which is a vector quantity, and inside the modulus, it means we are talking about the magnitude of force. 50 Newton, 30 Newton, not the direction, in which direction this force is acting actually. Alright, so be careful. If you are using the modulus, it means inside this modulus you are using to represent the magnitude of that vector. Alright, yes. Now my dear student, we'll proceed for the another thing. This was the story of magnitude. As we know that this quantity vector have the magnitude always the direction, so we will work for the direction now. Okay, and to use this direction, let me introduce from here the types of vector. Types of vectors. The first vector we are going to start here, the unit vector. Unit vector. What is the reason behind this unit vector? To teach you first, the reason is to explain the direction. Remember, write down the direct definition of this one. It is used to represent the direction of any vector. Unit vector always used to represent the direction. Okay, so you can write its property one by one. To represent direction, in short I'm writing, you must mention in your notebook. So to represent the direction, symbolically it is represent by hat or cap. Okay, if you are using thus A and putting a cap over the A, then it is unit vector A. Alright, unit vector A, this will be considered the unit vector A. So this is hat or cap, whatever, this is the unit vector. Sometime student, I've told you we used to represent the vector as this arrow, but this can be also represented by the, in some foreign book you will find by the bold letter. If someone is written by the bold letter, it means this is a vector quantity. So putting an arrow over the head of any quantity, it make it as vector quantity, or if it is written in bold, then it is a vector quantity. All right. And the unit vector, the first thing, the unit vector will be represented by this hat or cap. Remember, this is hat or cap. Actually this hat and cap is nothing but the direction of arrow. Okay, this was my arrow, this is the vector. All right, and I'm using this particular, you can see this one, and this is the unit vector, nothing else. Okay, here I'm writing A. All right, so this hat or cap actually used to make the unit vector, that is, it used to represent the direction. And this hat or cap, suppose I'm writing here the vector I, it is unit vector I, but this can be also written as, without putting this one over the head, that is this cap, it will be written in italic font. If it is written in italic font, this is also a unit vector. Remember, my dear student. Now come to the next point, my dear students. If any vector is written in this way, the vector A, as 50 meter east, all right, then what is this 50 meter, my dear student? This is nothing but the magnitude of vector A. All right, and what is this east? This is nothing but the direction of vector A. All right, this is the magnitude and this is the direction. So you used to represent the magnitude in this way and you used to represent the direction in this way. So this is a vector quantity. And another thing we are going to discuss here about the unit vector, which is the formula, and that is the very important. You must remember. Can you note down this one? What is that? So look at here. Suppose if you are having a vector A as 50 meter east. All right, 50 meter east. Okay, what will happen if you will divide this vector 50 meter east by its magnitude 50 meter? What will happen? What you will get? You will get only east. You will get only east. It means dividing any vector by its magnitude, it gives its direction. This is a very important formula. Dividing any vector by its magnitude, it gives the direction. Remember, this can be also written as vector A by the magnitude of vector A, it is the unit vector A. If you want to find the direction of any vector, then you have to divide that vector by its magnitude. Okay, and this is the very important formula. Now in this unit vector, the next thing you have to remember the convention note. This is the note point. All right, and what is this convention? What is the convention actually? If this is three-dimensional axis, x, y and z, all right, x, y and z axis, so to represent the direction along this three axis, we use conventionally unit vectors. Remember, what are the angle between this three axis? Between x and y, the angle is 90 degree. Between z and y, could you tell me the angle? Yes, it is again 90 degree. It is three-dimensional. All right. Now, my dear student, unit vector I cap we use along the x-axis. Unit vector j cap along the y-axis, and unit vector k cap along the z-axis. This is convention. Remember, everywhere we use this direction only. Whenever you need to represent the direction along the x-axis, you will use I cap. If you want to represent the direction along the negative of the x-axis, then you will write minus I cap. All right. If you want to represent the direction along the negative of the y-axis, then you will use minus j cap. All right. This is the small I, j and k. All the unit vectors are represented with a small letter. All right. Now, let me drop this. If you want to represent, all right, suppose here this particular man is going along the x-axis. Suppose in mode 2, all right, mode 2 moving along x-axis. Mode 2 moves 5 meter along x-axis. All right, from O to A, it is how much? 5 meter. So what we will write? Do we write mode 2 moves 5 meter along x-axis, this long thing? No. Now we are having a concept along x-axis. If it is the x-axis, now we are having the concept to represent with the unit vector. So directly we will write this OA, vector OA, as along with its magnitude and direction. So what is the magnitude? It is the 5. And what is the direction? I cap. All right, they're very simple. This is in meter. So mode 2 moves 5 meter along the x-axis. So we are writing here the 5 I cap. And length, so it is represented in meter. This is the SI unit. Now the next one. Okay, though, so the first vector was unit vector. We have studied in very detail. Now the next one, the second, parallel vector. Parallel vector. So the property of parallel vector, my dear students, look at here. If this vector is going in this direction and this is going in this direction, so these two vectors will be considered as, you must have to make in your copy this vector A and this is the vector B. If these two are parallel, it means direction must be same. So what you have to write in parallel vectors, you have to write the unit vector A should be equals the unit vector B. It means the direction must be same. And the second thing, what will be the angle between these two vectors? So you will find the two vector, it is inclined at 0 degree. Remember, it doesn't mean if the vector is located here or located here or located here, the angle between these two vectors are 0 degree wherever it is represented. If these two are parallel, then the angle must be how much? It is 0 degree, and this is called the parallel vector. So in this way you can represent the anti-parallel without taking much time. The anti-parallel, if I flipped this vector in this way, here the 90 degree, now here it is how much? The angle, and this is the example of anti-parallel. So let me put over here, all right, the anti-parallel. So the first thing, the direction of A, here the vector A, the vector B, the direction of A will be opposite to the direction of B. The second thing, theta will be how much? It is 180 degree, and this is called the antiparallel vector. Okay, yes. Now the next one, coinitial vector. The fourth one, no? Yes, the fourth one, coinitial vector. If the starting point of two vectors are same, okay, suppose this vector starting from here and this starting from here, then this is not the coinitial vector. So if it is starting from here, if two vectors, suppose it is vector A and this is vector B, alright, if two vectors starting from the same point, here the origin is same O, okay, then this two vector will be considered the coinitial vector. So in coinitial vector you have to write if origin are same. If origin are same, then two vector will be considered the coinitial vector. Now collinear vector. Collinear vector. Here the co means same. Okay, here the co means same. So collinear means if two vector lies on the same line, okay, lies on the same line, then the two vector will be considered the collinear. Okay, same line. Remember, if this is the line and you put two vectors, suppose here A and here B, okay, so this vector A and B are considered the collinear. Another thing, you can just invert this vector. If you are represented in this direction, then again these two vectors are collinear. So the concept between the collinear will be theta could be 0 degree or 180 degree, but the two line must lies on the same line. This is the collinear vector. Okay, my dear student. Now equal vector. Equal vector. Can any student tell me the equal vector? Number I forgot, so you will write by yourself. Here the equal vector. Equal vector. It is very clear with the name equal. Equal, it means the magnitude as well as the direction will be same. Okay, if you are having the two vector, suppose this is vector A and this is vector B. Let us suppose these two are having the same length. Actually I have made of the same length and the same direction. So this vector A and this is the vector B. What will be the property of equal vector? Magnitude of A should be equal to the magnitude of B. The first thing. Second, the direction of A should be equal to the direction of B. Okay. And the third thing, what will be the angle between these two vector? So the theta will be, here let me write, here the theta will be 0 degree. So these are considered as the equal vector. This is having the three property. Okay, so this is the equal vector. Now the next, coplanar vector. Coplanar vectors. So the two vector or more than two vector will be considered coplanar if they lies in same plane. Suppose over this board, if I placed 1, 2, what may be the angle, it doesn't matter, and this 3, all the three lies on the same plane. That's why this is called the coplanar vector. So you will write if the vectors lies on the same plane, so these all are considered the coplanar vector. Suppose if I made any vector perpendicular to the other like this way, okay, and now this is the perpendicular, if vector A, B and C, if I make this perpendicular to B, then this must be the perpendicular to the C also. Alright, so this is the property of coplanar vector. Okay, now the next, localized vector. Localized vector. What do you mean by the localized vector? So the vector whose origin is fixed. Origin is fixed. Remember, the origin is then it is considered as localized vector. Alright. So it is localized vector. Now the next. Orthogonal vector. This is very important. You will be asked to find the angle. You will be asked to find the magnitude, direction, etc., etc. But it will be written. It is orthogonal vector. So the orthogonal vector, if two vectors are perpendicular to each other, I put vector A and vector B. All right. Here the vector A and the vector B. So these two are orthogonal because the angle between these two vectors are 90 degrees. Sorry, here 90 degree. So this will be considered the orthogonal vector. All the vectors, if they are inclined at 90 degree, then they are considered the orthogonal vector. Now the null vector. Null vector. Null vector. If A is null vector, then its magnitude will be 0. Remember, its magnitude will be 0. Null vector also represented by the 0 over 0 and an arrow over its head. So this is the null vector. How this null vector actually formed? Suppose you are having the two vectors. Alright. If you are having vector A and vector B, and both are same in magnitude. Both are same in magnitude and opposite in direction. A, it is minus B. The direction of A, it is opposite to the B. And if you will add this two vector A and B, so you will get a null vector. Actually, this null vector, you can write this null vector represent the point. Okay, it localized at a point. And this is called the null vector. Now the next one, move to the next. It is, my dear student, the position vector. Okay, the next one is position vector. You can write in definition in your notebook the position vector. So the position vector, it represent the position of a point in a plane or space. Remember, it used to represent the position of a point in plane or space. For example, suppose it is the xy axis. Alright, and this is the point P. From O we are representing this point P. That's why this OP become position vector, because it is representing this OP is position vector. Position vector. Why? It is representing position of P. From where? With respect to O. Okay. So this is the position vector. If I write in this way, my dear student, this is the x-axis and y-axis. Here the 2 points A and B, and this is the O, and I made this 3 vectors. So what you will write about OB, this is the position of B with respect to O. Alright, and what about the AB? This is the position of B. You can see this is representing the position of B but with respect to which one? With respect to A. So this is considered a position vector. Okay, my dear students. Now we will discuss about the displacement vector. So the displacement vector, my dear student, we use to represent the displacement between 2 points, a vector that is called the displacement vector. We will study in very detail about this displacement vector. Okay, my dear students. Now, my dear student, we are going to study here start here the geometrical laws of vector addition. Okay, so laws of vector addition. Today we'll study about the triangle law, and then we'll continue with the parallelogram and polygon law. So we are having the 3 laws here: the triangle law, of vector addition, the second one is the parallelogram law, and the third one we have polygon law. Polygon law of vector addition. All right, one by one we will discuss all the 3 laws. The most important, it is the triangle law. All right, the triangle law. Triangle law, we'll start today. Student, we know that to make a triangle we need 3 sides. Okay, so these are the 3 sides. But here the law is telling you, if you are using any 2 vector to represent the 2 sides of this triangle, then the third side will be automatically the resultant of that 2 vector. What is the meaning of resultant? Actually, if we talk about in ordinary mathematical language, then 2 plus 3 is how much? It is 5. So 5 is the resultant of 2 and 3. Result is the resultant. All right, the net or the resultant, both are the same. So here again, if 2 vector you are representing with the 2 sides of a triangle, then the third side will be the resultant of that 2 side. But there is some rule to represent the 2 side, and there is a particular rule which will be the resultant. But first you write the triangle law. I am telling you, kindly note down in your note copy. Okay, so write down. If any 2 vectors are represented by any 2 sides of a triangle, then third side of the same triangle will represent the resultant of that 2 vectors. 2 vectors must be represented in same flow, and the resultant will be in opposite flow. Okay, student? So this is the statement of this law. You can also write this statement in this way, student. If any 2 vectors are represented by their magnitude and direction in same flow by a triangle, then third side of the same triangle will represent the resultant with its magnitude and direction in opposite flow. Okay, so this is the statement of triangle law of vector addition. Now we'll try to understand what is the meaning of this same flow and opposite flow. Here, students, look at carefully. Suppose I'm using here the 2 vectors. Suppose if this is vector A and this is vector B, so this is not the 2 sides of a triangle. Remember, you cannot represent this 2. If this vector starting from here, the second vector should not start from the same point. This is not in same flow. Same flow, it means it should be continue from here. All right, so these are now in same flow, and the meaning of this was that was the same that I have been mentioned in the here in the statement. And the third side, remember, the third side, if you are using this third side, to make the third side of the triangle. Now this is the triangle. If you are making this triangle in this way, okay, this is going in this way, and this way, it means all the threes are in the same flow. So this will be the wrong. So if you are representing the third side, which is the resultant, it should be in opposite flow. So in this way, this is the vector A, vector B, and this is vector R, which is the resultant, and this R is nothing but the vector sum of vector A and B. You will write the resultant in this way. Remember students, you have to represent the two vectors in same flow but resultant in opposite flow. And the next, what is the important to remember about the resultant? The head of resultant must be meet with the head of any vector. You can see both the head are at the same point. And the tail of the resultant must meet with the tail of any vector. Okay, now I am drawing here few vector to explain the triangle law, and then after I will give you some question for your practice. Here my dear students, if I am making vector A, vector B and vector C, or the resultant, vector A, vector B and resultant, whether this is correct? Answer is no, this is incorrect. Okay, now next, vector A, vector B and the resultant. Yes, whether this one is the correct? The answer is yes, this is correct. Okay, now I'm giving you two vector. You have to add with vector the triangle law of this vector addition. Okay, now I'm giving you two vector. I've given a vector here and here. This is A and this is B, and I'm telling you to put this two vector together to form a triangle using triangle law. So you will make this one A. You cannot change the direction, remember, and length also. So this is B and this will be the resultant. Head of the resultant will be in this direction. Okay, and you will write this R is equals to A plus B. Now the student can tell me, sir, it is necessary to put this B over here. Can we put this B over here also, although it is in the same direction, in same flow? Yes, my dear students, you can put that B over there also, like here, like this way. If you put B here, this will be also the same. This is A, this is B. But remember, where you want to put, you can put, but the resultant will not change. You can see. And this is the resultant. Now you can see, if it is the resultant of this length and in this direction, here again the resultant of the same length and in same direction. Okay, so the resultant is not going to be changed. You can put over here, you can put over here, but you must remember this two must be in same flow and the resultant will be in opposite flow. The same flow, what was? If the resultant was in this direction, then it must be in same flow. So the two vector must be represented in same flow and the resultant, it will be in opposite flow. Now for your homework, I'm giving you, this is your homework. Here the number of vectors I'm representing. One, 2, 3, 4 and 5. Alright. In this diagram, you have to find which vectors are the sum of which vector. Okay. Here in this combination, you have to find the combination 1, 2, 3, 1, 2, 3. Alright. And then you have to tell which one is the resultant and which two vectors are adding. You can also invert the vector For example, if you are finding vector 1 plus 3, here might be not the example, vector 1 plus 3, because 1 is here and 3 is here, it will not make any triangle. If 1 plus 3 is not equal to 4, sir, but 1 plus 3 equals to the minus 4, then you can write, yes, it's minus 4. So using triangle law, find the resultant. Okay, find the resultant in above question. This is all about the today lecture, my dear students. Thank you very much.